Now let us take an example of a reaction in order to understand and the effect of the different factors on the state of equilibrium. The example is of a reaction of a nitric oxide with bromine, which forms nitrosyl bromide. Now in this, two molecules of nitric oxide combines with one molecule of the bromine and to form two molecules of nitrosyl bromide. The enthalpy of the reaction is positive, so it's an endothermic reaction. The question is, what is the effect of the following on the above reaction which is at equilibrium? The first is increase of temperature. Once the temperature, if the system is at equilibrium, already at the state of equilibrium, we know forward reaction is endothermic from this sign, and the first condition is if the temperature is increased. We know since the forward reaction is endothermic, the backward will be exothermic, the increase of temperature will favor the forward reaction. So remember, equilibrium shifts in forward side. That means towards the product side. More amount of the product is formed. Let us see the second condition. Decrease of pressure. Here we have how many moles of the gaseous substances? 2 and 1, 3. Here we have only 2. So the decrease of pressure, it means we are increasing the volume, we are decreasing the pressure, increasing the volume. It means we are favoring the side which contains more number of moles of gaseous substances. Here we have on the reactant side 3 moles of gaseous substances. On the product side we have only 2 moles of gaseous substances. So the system will move back. So what will happen is equilibrium shifts to the backward side. Rate of backward reaction gets increased. Why? Because the decrease in the pressure favors to move the system to the side which contains lesser number of moles of the gaseous substances. Let us take third factor, addition of bromine. So it's the effect of concentration. Now if the system is at equilibrium and we are introducing this reactant, how we can write the Q for this? It will be reaction quotient for this. It will be like this. Isn't it? So this is the reaction quotient. It's the square of the nitrosyl bromide concentration upon the square of the nitric oxide concentration into the bromine's concentration. Now if more amount of bromine is added, what will happen is the denominator will become bigger. So what we find is the Q will become lesser than your K equilibrium. So what happens is, so now it moves back, but since in order to neutralize this, it moves in the forward direction. And we know from the Lee-Chatter's principle, in any case, the addition of the reactants is done, rate of forward reaction gets increased. Rate of forward reaction gets increased. Therefore, the system moves or the equilibrium shifts toward the forward side. Now, let us take the effect of addition of nitrogen at constant pressure. Once the pressure is kept constant, the volume will increase. The volume will increase will make what? The partial pressure to get lowered. So the system moves always to the side which contains more number of gaseous substances. We have already discussed this. So once this nitrogen is added at constant pressure, it means the equilibrium shifts to the side having more number of gaseous substances, and we know this on the reactant side we have more number of moles of reactants, gaseous substances. Therefore, what we can simply write is equilibrium shifts to the backward side. It moves towards the backward side because the backward side, the reactant side, contains more number of moles of the gaseous substances. Now let us take the last factor which is given in this question, is the catalyst. We already know the catalyst has no effect on equilibrium. It only reduces the time to achieve this, otherwise it has no effect. So we will write this answer on this